So how do we defend against these return-oriented programming? As we've seen, address space randomization does make finding the gadgets and the buffers and getting all the addresses just right, it makes it much harder. So that's a good first defense. Compilers can help by adjusting the kind of code they can generate. They can take care not to generate C3 bytes in useful places when they're not trying to write return instructions. And they can also add a bit of extra code before each return that doesn't affect what the compiled program does, but does make the return less useful to gadgets by sort of overriding a lot of extra registers, say. Some more direct defenses include control flow integrity checks that check whether, when you return, does that return address make sense at all. This is kind of a generalization of a canary. A canary double-checked that something nearby the return address was exactly what it should be. But in general, for programs that are not generating new code on the fly, then you can predict in advance and statically all the places that make sense to return to and just reject at runtime any attempt to return to other things. Making this efficient is tricky. You can do it with a combination of compiler and hardware technology. So LLVM has some CFI support where it inserts some special checks and uses link time optimization to make sure that it can efficiently execute those checks for each return. Intel chips with control flow enforcement technology provide hardware support, and they do this by whenever you do a call and return, not only is the address put on the C stack, but there's an extra stack set on the side where that return address is put. And so when a return instruction is executed, the processor can double check that the return address has not been changed since the call happened that the return is matched to. Windows does something similar at the operating system level. So it's kind of in between these compiler and processor-based technologies. The operating system keeps a per process bitmap of valid return and jump addresses. So when you make a call, it sets a bit to say, this region of memory that I called from, that's a valid place to return to. And if the return address is not in one of these places where a valid return address sits, then the return can be rejected.